on this computer. All right, here we go today. All right, let's dive in, and anyone that please be interactive. So I want to hear what you guys think about these things. Here's what we're going to cover today. I already kind of mentioned. We're going to cover structured task scopes, the two that are going to be used in 1C, shut down on failure, shut down on success. I noticed some of you were using a different fork mechanism. Don't do that. Use these. We want to use these on purpose, okay? And then we'll go through assignment 1C. We'll talk about the difference between controllers and services. It's very important to understand what each one actually should be doing, right? To make sure that we have the division of code correctly. And then we're going to finish up by kind of dipping our toe into assignment 2 a little bit. Because so far, I know the course is microservices. We haven't written a microservice yet, not really. We kind of have, but we have a monolithic program. We don't have a microservice architecture. So we're going to talk about monolithic versus microservices, pros and cons, and all that stuff. All right, sound good to everyone? All right, let's dive in. Please stop me if you do have any questions. All right, first, shut down on failure. You are going to use this one a couple times inside 1C, so it's important to understand it. Remember, it does what? What does it do?
Runs all tasks, but it stops if anyone fails.
That's right. It runs all the tasks and stops if anyone fails. That's the most important part of this that you need to recognize. This will help you understand when to use it in the assignment. Okay. Shut down on success. Someone other than Elle, she answered the last one.
This will exit once there is one success.
Perfect. This exit once there's one success. What if one fails first?
It just keeps going.
Just keeps going. Good. All right. Very good. All right. Remember when you're coding these things up that with shut down on failure that I'm using futures. Don't forget about the futures because I'm going to aggregate the results together. That's not true. Well, it's kind of, I'm going to aggregate the results together. It's different on the shutdown. Now my brain just got set. Shut down on complete. It's different there because I'm only passing back one and the results will only come back once. Scope fork provides a new subtask, and don't forget the scope join. That brings everything back together. Okay. You guys understand these things, these concepts? They're important for the next assignment. No questions on shutdown on failure? Okay. All right. Don't forget, you will use this in the next one. You'll throw if failed. You're going to throw an exception outside of the task. If I don't put this in there, what happens if an exception is thrown in one of the subtasks? Anyone know? Aaron, Reed, LaShawn, Ronald, anyone?
I think it gets swallowed.
It does. It gets swallowed. Yep. So up above, if you want to know if something failed, then you need to make sure that you're throwing it failed. If you don't, it gets swallowed. You'll never know that something failed. Okay. All right, and don't forget on the response, you're going to get the values from the futures. Don't forget that part. That's important. Okay. All right, shut down on success. Again, I have the scope here. Notice the difference here on result, scope, result. The value of the first one that succeeds goes into result. I can just return it from the scope. Okay, right there. It's whoever finishes first. All right, same concept with the join. I'm bringing it back together, and then I'm shooting out my scope there. Okay. Any questions on that before we dive into servers MVC real quick? You guys understand these are important for the assignment coming up. And for those of you that haven't taken the test, I just answered like 4 questions. So refresher for you guys. All right, let's talk about controller and service, because you guys have been dealing with this a lot already. So it is important to understand what the controller is used for and what the service is used for, and why we have them disconnected the way that we do. Right? Remember, the controller itself is handling HTTP requests. So when I get something in from an HTTP request, what does it look like? Any ideas? Have you guys looked at what's sitting there? Nothing? What are
Yeah,
you
I
doing
mean,
in the
there's-
controller? Yeah.
There's ways that you can get like the HTTP verb that was called. You can get the headers. You can get the well, your input parameters will give you all of the like if it's a post request or request body, things like that. Is that what you're talking about, or are you talking about something different?
I'm talking a little bit different in the payload. When I call an HTTP request, I'm calling a REST endpoint most of the time. All right, especially when we're talking about the stuff that we're doing, right? I have a request coming in. Someone wants me to do something. I'm going to get what the URL, the URI was that was coming in, and I'm also going to get a payload that came in with it. Most of the time, you guys have to realize that when we push things out across a network, it all turns into a bunch of bits, right? And they're streamed. Unlike in memory, there are a bunch of bits, but there's some structure to them. Inside these streams, it's a stream of data. So I'm going to have to encode and decode that data. I decode the data when I bring it in. On the request, on the response, I'm encoding the data from my data structure into a message that then gets passed to the other side. The controller, its whole purpose there is to handle all of that encode decode. So I'm going to take a string or a JSON. Sometimes people call a string a JSON is a well-formed string. You can kind of think of it that way. I'm going to convert that into something that my program can understand, because my program, it can understand strings, and I can read those strings and interpret those strings. But ideally, we want to do all that encoding and decoding in the controller. So now when I pass things down to the service, I can call a service method with parameters, and the parameter is more than just a string to decode. So that's the whole purpose of that controller layer, right? So put in the controller layer all those things that correspond to encode and decode. That's the primary purpose of it. On the service side, this is all your business logic. I'm going to handle transactions there, validate the parameters that came in. Are they what I expected? And then this is where I'm going to also interact with the repository layer, the data layer, and other services as well. Okay. It is important in this next assignment to understand that. We're going to see that in previous assignments, to get the things to pass, I maybe did a little bit of decoding in the service. We're gonna try and push that up into the controller this time. Okay. Right. There are some benefits to this. Some of the benefits are a scalability, maintainability, and testability. It means I can test the service without connecting up to the internet and having a RESTful interface, having another program call it through the REST interface. I can test the logic in the service independent of encode and decode. I can do the same thing with the controller. I can mock up a backend service, put it in there against the controller, and I can now spit back results and make sure that all my encode and decode are happening appropriately. This model you're going to see in a lot of programming languages. It's very common, but we want to make sure that you guys understand that. So you're going to see it in droves in this next assignment. Okay. Any questions on this? important to understand.
yeah.
Go ahead.
I have a question about oh, sorry. I have a question about the controller. In the video, they use the language of marshalling and unmarshalling. Is
Yeah.
that the same reference?
Yeah, so marshalling and unmarshalling is taking a string and creating a data structure from it. That's the
Okay.
same concept. Encode and decode, same concept.
So when you decode, it's unmarshalling, and when you're encoding, it's marshalling. Okay.
Marshalling. Yep. Yep, you got it. Now, there's something really cool. I thought it was going to take off, but it didn't. I worked for Intel. Intel created this in conjunction with Micron, created this new type of memory called Optane. Did anyone hear about Optane? Actually, pretty cool stuff. Optane was persistent memory. So we took the von Neumann model, which is the typical computer model that you have, where you got the CPU, you got memory, you got storage. Memory's volatile, meaning I turn off the machine and it goes away. It's fast. And then I've got storage, persistent storage is on a spinning rust in the past, or if you're old enough, you might remember the magnetic cores that they were using. But now almost everyone is not using spinning drives anymore. They're using solid state drives. Well, these Optane drives kind of fit in between memory and drives, a lot closer to memory. And what we found with this is there was no more need for a database to persist my data structures. I could persist them directly from memory. So there was no marshalling or unmarshalling of data structures so that they could be put out on a drive. I could just take them in memory as they were. Marshalling and unmarshalling code takes several cycles in the CPU. It's not very efficient, typically, right? There have been some accelerators that have been built in the CPUs now that will handle some of that stuff. But in general, there's a lot of clock cycles wasted in there. So think about that when you're writing your code as well. That this is an area that you can look for improvement in performance, is marshalling and unmarshalling, or encode and decoding code. Okay. All right. Any good question? Any other question or questions? Nothing? All right. Let's go to assignment 1C. So you're going to be working in the movies X directory this time. There's 4 files that you need to mess around with. Server beans and movies controller are almost identical to before. Movies controller, though, make sure, and we'll go through it, but make sure that you're doing all your encode and decode in the controller, not in the service. Movie services or movie service there's a lot more changes in there. And there are some changes in movie sync proxy test as well. Not as much as movie service. That's where we're going to focus most of our time this time. All right. So I'm gonna walk through the code right here. I'm not quite sure if this is big enough. You guys can let me know if that's big enough to see, or is it too small?
Maybe just like a hair bigger, just like a little bit.
A little bit bigger. Let's see if I can change the resolution on my screen. Is probably the easiest way to do this. So forgive me, guys. A second, and we're going to go through, and you can ask any questions you need to. I may tell you I don't know the answer, or I'll just make something up. Either way, we'll get an answer out of me. All right, we'll make it nice and big. Oh, I want to keep the changes, even though this is a horrible resolution. It will be nice and big. All right, is that better?
Yeah, it's better. Thank you.
Okay, so let's first dive right into the controller. This time, make sure, especially down here on the searches method, that you're doing all the encode and decode in here, right? Before, if I remember right, there were some issues, and we pushed some of the encode decode down into the service. Right here as well, you've got you've got things you've got to take care of. Three areas here. This should be very straightforward. You guys should know how to do this stuff. You've all pretty much mastered the controller aspect of things. All right. Let's walk through services though. And we put some skeleton code in here already, but you're gonna find that don't miss the small things like putting a bean, making sure that's a bean factory method. And then let's look at right here. So the idea here this time is on this search where I have a regex that I am going to use structured scope here, and that I'm going to return a list of movie objects here that match this, right? The difference here, no, this one's the same, I think pretty close to what we did last time. Make sure that you're calling the helper methods that are there to get the current list of all the movie objects that match the pattern. You're also going to have to turn a regex into a pattern, and there is a utility to help you do that. There's a lot of good help in the videos that I'll make sure that are available for this. All right. Also, don't forget your join here, and then also we are going to throw an exception if you cannot find a movie that matches. We're going to throw an exception. The exception is defined, so make sure that you use that exception. All right, you may have to fill out some more information on that exception, so take a look for that. Okay. Also, use the helper method there to return a list of movies, not future movies. A list of future movies. All right, make sure that you're returning the proper list. Looking at this by itself, which scope are we going to use? Any clues? I'm returning a list of movies. I'm going to iterate over the movies, and all my subtasks are going to check each movie. So what structured task scope should I use in this one? What do you guys think?
Structured task on failure.
Yeah, task on failure will be that one. Okay. This one is going to be a little bit different, right? This one I'm calling a helper method to concurrently get the list of all movies, right? I have multiple queries now that are coming in, right? And I want to locate all the movies whose ID match the list of queries. Now, I'll probably still do the same thing on this one as well, right? I'm going to use that same scope. Look at each to-do. Do not remove the to-dos, please. It makes it easier for me to look at the code. All right. But make sure that you are throwing an exception if you need to. And also make sure that you have the join right here. I just gave you the answer there on the barrier synchronization. All right. Here's the make patterns helper function. You should most definitely write that out, and that's for a list, and then there's one for just a normal pattern. Okay, this is another helper function down here, and another one here. So there's quite a few things that you guys need to write this time, and there's concurrency built in. Okay, so you're going to see that you'll probably have subtasks of subtasks in some instances. This one here is a little bit different. The find match is async. So watch out for that one. Shutdown on success. What's the difference with can't even talk. What's different with a shutdown on success? Anyone?
Returns on the first success, and every other task shuts down.
Yeah, so as soon as I get a match, boom, it's going to return. Okay. So keep that in mind. The code on this is a little bit different than the other shutdown on failure. Okay. So take a look at that code. There is more out there for you guys to work through. Or there's more videos out there that will help you get through these things. If you get stuck, please put things in the discussion board. If you are using ChatGPT or the little AI assistant that's sitting right here, make sure you give it proper context. I've noticed a couple people using it. They said they use it, which is great, but make sure that you put enough context into your prompts so that they know exactly what's going on. And that we're following what we've been learning in class. So you've got to give it enough context to help you with any syntax maybe that you don't quite understand or whatever the case may be. But you need to feed it with context. You need to feed it that we are doing, scope tasks that, instead of just open, or structured tasks instead of just open tasks, for example. Okay. And then you're going to make some changes over here in Movie Sync Proxy as well. And just look for the to-dos. I know there's something in there. Maybe there isn't. I thought there was, or I grabbed the wrong thing. Sorry. There, Movie Sync Proxy. There's some things that need to be done in here. Most of it you guys should be familiar with. So most of your time, I would guess, is going to be in your movie service. Okay. Any questions, concerns? Lots of concerns. Okay, nothing. I'm getting nothing fun from the peanut gallery today. All right, let's talk about architectures real quick. Or not real quick. We'll make sure you guys get enough time to finish if you need to finish. So far, we have written a single executable, and this is where we sat a long time ago in the way that we developed applications and the way that we developed solutions in the world. We would write individual modules or libraries or services, but they all resided in the same process space. Or maybe I had multiple processes, but they all sat in the same memory space. So they use shared memory or they use something like that. And that's kind of what we call a monolithic approach to architecture. Where a microservice, the main difference with a microservice is that my service itself can live in the same host, sometimes in the same process space, but most of the time it's a different process running on the same host, a different network, a different even type of architecture underneath the covers. The idea here is that they are segregated, and there's some madness, or there's meaning to the madness on here, and there's also some downsides we need to look at. Okay, how many of you, I would say by show of hands, but I can't see anyone, how many of you have written microservices already? You're already familiar with them? Speak up for now, or give me a thumbs up in the chat, and maybe I can look at the chat.
Written a bunch.
A bunch. All right. That's Aaron. I recognize the voice, Aaron. Anyone else? All right, there's my chat. I have not. Read has not. Okay. I have. All right, good. So for the people that have, you're going to help with the ones that have not, because it takes a little bit getting your head around, and that's what we're going to focus on today, because as we move forward in the assignments, we are going to move more towards microservices. Assignment 2 is all about microservices. I don't want you guys doing it in 1C. Okay? 1C, we're still writing one service. We're not writing a whole bunch of small little service. We're writing one service. Okay? So you should recognize here, though, that monolithic is I'm running those services in one process space. So if I need to scale, what do? I launch the whole monolithic application on several hosts. I put a load balancer in between, and I handle everything that way. But everything in my monolithic program is sitting in there. It doesn't, to do its work, it doesn't have to go outside of its process space. It may get something from a database or a file system. It may have a shared library, but it's being pulled into that process space. Okay. With a microservice architecture, it's a little bit different. The difference comes in that the microservices themselves can actually reside on the same host or in separate hosts. In the example I have down here, I have 6 hosts running, and I have 2 instances of service A, 1 instance of service B, and 3 instances of service C running. Now, the reason I may do it this way is because I know service C is kind of a process hog, and it needs more CPU cycles or more memory or whatever it may need. It's a resource hog. So I'm going to put multiple out there, and I'm going to load balance any calls to service C over across those 3 hosts. So the difference that I get here is that if I need to scale on the left with monolithic, then I actually have to duplicate, the whole application gets duplicated over and over again, even though maybe here on the left, A does a little bit, B hardly does anything at all, and C does all the work. I'm wasting resources here. Right, so that's one of the problems with monolithic is if I want to scale, I have to scale the whole thing. I have to just make a replica of it and put a load balancer on the front. Over here on microservice, though, I have more granularity where I can take those microservices that are using a lot of resources and replicate them as I need to. But there's some overhead with microservices. I'm going to need something that coordinates, and I'm going to need an AI gateway, something that coordinates all these microservices when they get spun up, where they are. Someone needs to pay attention where they are. And then an API gateway gives me a gateway into accessing all the APIs between all those services. Where over here, I don't need a gateway. I just come directly into that application, port, 3,000, port, 4,000, whatever it is. Here, I've got several hosts at different ports. Probably it's a lot more complicated in understanding them. So I'll take a little pause here, and I'm asking you guys some questions. So I need some feedback. Which one would you rather program in and debug in and write assignments in class in? Go ahead and unmute and let's have a conversation.
Well,
I would think microservice just because it's a lot more independent and less dependencies. When there's a lot of dependencies, sometimes you see unexpected errors.
Oh, that's a good one. Yeah. So there's some isolation in microservices. Good. All right. Anyone else?
Yeah, just to add to Jonathan, I would say decoupled.
Yeah, they're decoupled on the right. They could be decoupled on the left, but there's nothing preventing it. We're going to talk about coupling here in a little bit. What else?
I would say, just from real world experience, sometimes monolithic has its benefits in that you don't have to provision each one of the services to get a single front end to load if you don't have an API gateway in some cases. So
Yeah, I agree. I agree with you. I would, if it's just me and I'm just programming and I'm not concerned with anything else outside of that, The monolithic one's way easier because it's a contained system. And so I can put a breakpoint in the spot I want to hit, and I can run my app and it's going to hit the breakpoint. Where the microservices, you know, it's like, yo, you got to spin up Docker containers on your PC and try to run all these things at once, or I don't know, there's other strategies, but I guess you get my drift.
You are absolutely right. Microservices are much harder to debug when you're coding, especially if you're debugging interaction between services. All right, anything else that would lead you towards one or another? Anyone? Anyone? All right, let's talk about these. Oh, go ahead.
I know one thing what they definitely since I work on the front end for a lot of things, it just gives me a basically what I usually need to do often would be sometimes we need to deploy one thing and then have another thing taken down. It just seems a lot easier to deploy service like to upgrade service A without affecting service B, if that makes any sense.
Yeah, absolutely. If I'm doing rolling upgrades or things like that, I can keep the customer of my application, I can keep them happy and running, and they don't even know I've been upgrading the back end. So that's much easier at the microservice than monolithic.
Yeah.
Yep, absolutely. Absolutely.
Yeah, I think I'd rather have the microservice. Just I'm thinking more from like a workflow perspective. When I was working on microservices, we had multiple teams across the world, so you only had to worry about yours. And if you broke something, you know, it was only you and a few other people, and not too many cooks in the kitchen.
Yeah.
Bug the monolith and affecting each other that much.
So one of the largest monolithic programs I worked on was with Lucent Technologies and their division of Octel. Anyone know what Octel did? It was a massive monolithic program. Anyone have any ideas what Octel? You all have used Octel's service. Maybe some of you've never used it, but voicemail. In fact, the voicemail system that you have on your phones, that AT&T, T-Mobile, Verizon, they all use an Octel voicemail system. And it was a huge monolithic program, several million lines of code. It took 21 days to build that code. It was a disaster to build and test, 21 days. So imagine, like you said, I've got teams all over the world checking code in, and I'm building this thing, doing all their merges in and making sure that it tests and runs as it comes out the other side. It was a nightmare. If we were doing microservices, I could do continuous build and test without having to wait for this massive thing to finish. So I will tell you guys some horror stories about that another time, but we will move on. So let's take a first look at one of the benefits and downsides to microservices. Some of the gotchas we have to watch out for if I can move forward. First one is the team aspect, right? So you guys have already kind of mentioned this. And it's funny because with microservices, I can set up my repositories so that each microservice is completely independent in its own repo, or I can put them all in one repo. But with monolithic, it's much harder to have them in separate repos. I've seen it done before, and it was a nightmare for the developers, but it made it easier for some things on the build on the back end. But generally, monolithic, I have one repository for my version control. Anything I check in could affect everybody else, unless I have very well-defined interfaces between the services, service A, B, and C. Now, this takes discipline, but it can be done. And if you can get 1,000 programmers or a couple hundred programmers that are working on your big project to all consistently do that and follow the paradigm of interfaces and cohesion and decoupling in your monolithic, then you're not going to have the problems that a lot of people have, because you have agreed interfaces and all that's all hunky-dory. On the microservice side, you have to have an interface. If you don't, then service A and B can't talk to each other. And service C, you know, if it doesn't have a defined interface, no one can talk to it at all. So there has to be some kind of interface defined. So in some respects, microservices force us to have cohesion and to have some sort of decoupling. Now, we're going to talk about, there are some other types of coupling that occur, which we'll talk about. And they're kind of sneaky. And there was a major outage in AWS because of some coupling that no one knew about. They were hidden couplings. In a monolithic program, I can run static analysis and I can see a lot of my coupling between the services. And there's some great tools out there that can help you with that, with static analysis on your monolithic code. On your microservice code, that's a little bit more difficult to find those things. Static analysis typically isn't good enough. You need to move to dynamic analysis to look at those sorts of things. But the first benefit here is version control, build systems. I can focus on building one service at a time. If A is a program that changes a lot, I think Jenna was mentioning that, I'm going to only affect my small team working on service A, and B and C should not be affected if I'm not changing my interface. Right? It kind of forces us to do good team programming. Any other comments around version control? Do you see the difference? See how it can work? Modern version control like GitHub has the concept of a repo that has little microservices inside there that can be independently deployed and managed that way. It's actually pretty cool. So I can put them all under the same umbrella, wrap them together and push them out. But if you're doing large development, most of the time, each microservice will have its own little repo. Okay. All right, next, let's talk about coupling more. So with monolithic, the first coupling that we run into is coupling caused by bad programming. And that is without defining well-defined interfaces, without having cohesion, coupling can occur very quickly. So that service A and B may be tightly coupled because A is calling things directly inside B. It's not calling the interface to B. I've got type coupling in there. So if any logic changes in B, it affects A. That's really bad, right? I can also have build and deployment, which we already talked about. There's libraries that in a monolithic program could be causing some coupling that, you know, A and B both use this one library. The one library changes, boom, I've got A and B down. Or if A wants something jammed into the library and B doesn't know about it, that's another problem, right? So those are forms of coupling. Someone asked a question in the chat. Let's see. 2 new messages. Yeah, good point, Jonathan. Yeah, it can be a nightmare. On the microservice side, this could be really interesting because I can do build, deployment, libraries, and a repo all independent of each other. I can segregate them so they're completely independent. And if your organization is doing it right and you have a systems architect, they're going to find different ways of different programs taking advantage of service A, B, and C independent of each other. Right. And this could be a very good way of reuse, which is another huge benefit. Most of the time when I talk about reuse in monolithic programs, I jam them into libraries, and those libraries get used over and over again. That is one form of reuse, but nothing like what we're seeing with microservices. Now let's talk about some hidden coupling that you need to be careful of. I've seen this, I've done it inadvertently, and I've done it on purpose too. So in this case, you can see that I've got coupling, but if you notice here, service A, B, and C don't talk to each other at all. So at first glance, if I put my hand over the things on the bottom, hey, I've got great decoupling between A, B, and C. Is that true? My answer would be no. Because in this case here, service A and B are both reaching down into the same file system. They're doing things in there that causes a coupling between the two. And it causes a coupling without a defined interface. I'm just going to drop files in this file directory and I'm going to pull files from there. Unless it's defined somewhere, I need to define it somewhere. I have an invisible coupling that is going to be hard to find later on. Right? Same thing with the database. If I have service B and service C that are accessing the same database, the same tables in a database, any change I make to C could have a negative effect on B. So I need to be careful of that. And the same thing with libraries. Now, you guys are probably saying, well, wait, is Dr. Darren saying every service needs its own database? Every service needs its own libraries. I can never share libraries between things. No, I'm not saying that. What I am saying is you have to identify these couplings so that you understand them and that you put the right change control in place so that you're not stepping on each other. So there will be times where, a lot of times where I've got a common library that I want all the services to use. For example, if I have an authentication library, an OAuth library, and I want to make sure all my services are using authentication, then I don't want to write that for each one. So I'm going to use the same library, but I'm not going to change that library based off of one service's needs. I'm going to understand who's using that library. So make sure that you understand that this is a way of coupling. All right. Can we think of any other hidden couplings? Anyone got any other hidden couplings that you can think about?
I don't know if this is a coupling or more of like a consolidation of logic, but what about like orchestration layers, where one of the microservices acts as an orchestration layer to disseminate data to the front end?
You know what? That is a good thing. There is some kind of coupling between the orchestrator and the service, but it should be done through the interface, not through just dropping something in a directory. That's not well defined. Does that make sense?
Yep. Yeah, it does.
Or through events. Events is a good way of having communication between services in a decoupled way. And we will talk, you don't always have to call an interface to get information from service A to B. I can use a message bus, and I can use a publish and subscribe type of pattern to do that sort of stuff. But we'll talk about that later in the course.
What about cron jobs or scheduled tasks between services to sync data? Is that a form of
Ooh, that's a really nasty coupling that would be hard to find. Yeah.
I'll show you where it is. Yeah.
Yeah, that one, and that one's hard to find because I bet it's not documented very well, or it's not documented with the code. Right. Remember, it's important that someday in 2037, and hopefully I'm still around and I will make a boatload of money, there's going to be the end of time. And anyone that knows Linux knows what I'm talking about. 2037, the clock time on Linux runs out. So we're going to have to go make a bunch of code changes. And someone's going to be reading that code. So if you've got a hidden coupling somewhere, you could easily break things. In fact, we're finding people trying to move off of mainframes are having a bear of a time because there's a lot of coupling that no one quite understands, and it turns into a spaghetti mess.
Yeah, one annoying one is actually time zone.
Oh, yeah.
And so if you move, like IBM has their own special time zone things, and then you've got time zone concerns with like the different operating systems. And so you end up like this thing is on one system and that thing's on another system, and then you switch the underlying systems, and all of a sudden weird stuff starts happening.
Yeah, so you have some kind of dependency on time zones. You got
Yeah,
some
because part of your interface is handing a time, like a date timestamp or
A date
something from
timestamp,
place to
yep.
the next, and then they get out of whack.
Yep, that could be a problem. So if you notice the difference between up here where I'm calling resources directly, like, hey, if service C wants to get some information from service B, I'm just going to reach into the database. You're going to get your hand slapped. That's bad. Instead, I should be calling the interface to B to get that information from B. Okay. This decreases the coupling. There's still some coupling, but it's out front. It's not hidden. It's well defined. It's something I can use. I still purposefully put coupling between service B and C by using the library. Because, hey, that's an authentication library. I'm okay with that coupling. It's very well known. They both are dependent on it. I'm okay with it. I have written code and seen code where service A and service B have dependency on each other. That's typically a bad idea. Typically. You can get in when you get some of these really large microarchitectures where there's several dozen microservices, where you create these dependency loops. And this was one of the problems that they had in AWS with the major shutdown in at Thanksgiving. I think it was 2022, I think, if I remember right. They had some circular dependencies in a very complex system. And when one went down, they had cascading failures everywhere. It was a total disaster. Right. But Amazon reimbursed all those people for all of the instances that weren't accessible during that time. That was wonderful for them, even though it was the day after Thanksgiving, one of the biggest sales days of the year. So here's some things we can do about decoupling things. All right, let's look at another consequence of using microservices. So on the monolithic side on the left, if service A wants to call service B, I just call a function call. And it knows, it can find the object in memory to call that function on. It brings in the whole stack, it brings in some heap, and it goes and does its thing, and it returns what it was supposed to do. On the monolithic side, it's pretty certain that when I call that method, if I haven't messed up the code, it's going to return. It's almost guaranteed it's going to return, right? It's highly reliable. It's in the same process space. It's in the same memory space. Even if I'm doing multi-process in the same process space, it's pretty reliable. It's still very reliable on getting this stuff back if I'm using shared memory. The latency is pretty low because it's all happening inside the CPU. And I can push a lot of stuff in memory, right? Because a lot of times I may just be passing memory back. Or pointers to places in memory. So let's say that get items passes back 1 billion items, right? I could just point to the front of a linked list coming back and I get the answer right away. So that's infinite bandwidth, low latency, high reliability, easy to debug. I can put a breakpoint right on that get items on service B. And guess what? When I go next, I can step right into service B and start looking at the code and seeing what's going on. So that's monolithic on the left. It's very different with a microservice. If service A wants to call a method in service B, what do I have to do? How is service A going to talk to service B? They're not on the same machine. They may not even be on the same network. How am I going to do it, guys?
You either have to mock it or make sure both services are running at the same time, and you can view the logs of both as you test it.
Yeah, but how is service A actually going to call a method on service B when it's in a different process?
You have to make an API call.
Yeah, you have to make an API call. What does that mean when it makes an API call here? What's happening?
It makes an HTTP request
Yep.
to a one service to decode it to hopefully get the payload back, and then you have to decode it, and I'm gonna mix it up, but basically you need to make sure you make the HTTP request with the expected payload that each service requires and validate the data that comes back.
Yep. The difference in number of compute cycles. Now, this is how many cycles the computer's using for each, for each operation, right? So the number of cycles it takes to do a call here is very small. It may only be 3 or 4, maybe a little bit more if it's a really big set of parameters coming in, but it's small. It's very small. And if I go all the way down to the machine code. Over here, we're talking close to between 50 and 100 cycles. And one of the problems I have here is, what if when I say get items and I send an HTTP request over, what if when I send that over, this is running and it dies? Am I ever told? Does it ever come back? Man, that could be really tough. Over here on the left, I'm guaranteed it's going to come back, or the whole program dies, right? Over here on the right, I'm still running. I'm okay. I'm not getting a response.
Yeah, sometimes you'd see some bad status codes, but that really depends on what you're working with.
Yeah, sometimes you get status codes. What if, though, it's just B is taking a long time? What if it's just chunking on something and I haven't got a response back yet? So I have to have extra code in here to say timeout. Because if I send something and it disappears and I don't get anything back.
Usually
maybe,
at that point, you need to reach out to, like if you're sending it from like service A to B and it's taking a while to come back from B, often you might have to go to the developer of service B and have them check the logs.
Yeah, exactly.
Which it's not the greatest of systems, but that's what you typically have to do.
Yeah, and then think about this. What if your team is where your company's follow the sun, and they have programmers in Poland, India, China, and the US. And Service B is that team in India. They're 12, 14 hours different. It may take you a day to debug a simple problem. So, hey, this could be a problem, all right? So reliability is a question mark. High latency, this is going to take a lot longer to do than on the left. And also, if I'm passing back from service B 1 billion items, is it going to take longer to do 1 billion items across a network than just hand me a bunch of pointers to memory? You betcha. So I've got limited bandwidth as well. So when you are programming in microservices, you need to pay attention much more than you did in Monolithic to what you're passing back and what you're passing into parameters. And these interfaces get locked down much sooner than they do in a monolithic program typically, right? So remember these things. These are important things. You will see them. And this will help you also with your architecture on when you want to do things in your process and when you want a microservice to do it somewhere else, right? And you want to make these as bulletproof as you can. And there's some techniques we'll talk about, but you also want to make sure that you're not sending the whole world over across this network, that you're limiting. Okay. All right, addressing. Let's talk about addressing. So in a monolithic program, addressing service A and B are in the same memory space. So if I need to call service B, it's really easy. I look it up, it's there, and I can bring the code in, run it, and I'm off to the races. On a microservice, A and B could be on different hosts or networks, and I need some way of knowing where service B is running, probably an address and a port somewhere. If you are hard coding addresses and a port, you just created a mess, something very hard to debug what's going on. And you also created a very rigid microservice architecture because now you've locked service B and A to specific IP addresses and ports, right? There's other techniques we should be using to do that, which you're going to see here in a little bit. Okay. All right. So a simple microservice architecture, and I think this is the last slide, will look something like this. And this is just a simplified version. There's some that have quite a few other helper or controller services. But if I look at it, it's like this. In this case, I've got 4 microservices running. I have 2 instances of service C running. When they fire up, they're going to register with the service registry. And inside that service registry, they're going to say, they can say a bunch of things, but the primary things you need to have in there is the name of the service, probably its endpoints, and where I can access that service. So host name or IP address and port number, right? The service registry will have that. So anytime a service comes up, it's going to register itself with the service registry. When it goes down, there tends to be a signal hang up, and the service registry will let that go. In some systems that are highly reliable, the service registry will do a periodic ping to the service to make sure it's still awake, still alive, and can take work.
Question for you.
Yeah, go ahead.
The service registry, is there like some sort of app that, or like, is there some tool that people use for that?
There's a lot of tools out there that are being used for that.
Okay.
In the Kubernetes space, there's Istio, that's a service mesh, and it has a registry in there. In Docker, you're going to see Docker Swarm has a service registry built in. And in fact, you can name the services. But the more modern orchestrators, microservice orchestrators, all have service registries.
Okay, so if I was operating outside of that, where let's say I had the services like spread across machines or on different cloud services or whatever, is there a way for me to register or to have that same capability?
Sure, you can write your own little microservice that does a service registry.
Okay.
Yep, and then what you do is you put that behind a load balancer, maybe if you need to, and you use a DNS domain name service, so that service A, when it comes up, it says, "Oh, I need to register with service registry."
Okay.
So it'll name resolve and then attach to that microservice.
Got it.
Yeah, that's in the container ecosystem. They play some really interesting games. They basically virtualize the network and including naming services and so they kind of mimic this architecture by controlling the whole network. And they do something called overlay network, which is a really cool way of doing things.
Okay, that makes sense, because it seems like you would have to control the network, because otherwise how would, like, if I am a service and I start up, I might be just one service of, I might be one instance of 3 services behind a load balancer. I would want people to go through the load balancer, not hit me directly.
Well, they don't hit you directly. They hit the API gateway.
Oh,
So
okay.
Yeah, the API gateway acts as almost like a director. So this is an important aspect here too. The API gateway, if someone wants to talk to service A, they don't just talk directly to service A. They talk to the API gateway that then routes the traffic to service A. All right, so when I come up and I say, I'm service A, and I give my endpoints, those endpoints get registered into the API gateway. Someone comes with an endpoint, it redirects it to one of the service A's that can handle it. So a lot of time API gateways are a load balancer. So I don't need another load balancer for service C. In this case, the API gateway acts as my load balancer. Some API gateways are really smart about it. Some are just do round robin, which tends to be a pretty good strategy most of the time. Okay, do you guys understand how this is working? Service A, B, and C, both C's, when they come up, they tell the service registry, here I am, here's my IP address, and here's my port. And it may even also say to the service registry, oh, and by the way, here are my endpoints. And then when an API gateway comes, when a request comes in, the API gateway queries the service registry and says, what you got for me? Anyone can do this work for me? And they go, why, yes. Service B can do that work for you. Then I just pass that into service B. Okay. Any questions on this? This is important stuff here. Understanding, because this is a simple microservice architecture. There are many different ones that are much more complex, but these are the basic concepts. All right, no questions on this? This sort of stuff will be on exam 2 for sure. All right, not exam 1. Don't worry for those that haven't taken it yet. It's not on exam 1. All right, no questions? That's a lot to cover. We're starting to get into some real fun stuff now. We're going to really be hunkering down on the concepts in assignment 2 on these microservices. You're going to start seeing, as some of you have already mentioned, it can be much more difficult to program and debug in microservices, but IntelliJ has some really good tools where I can fire up multiple microservices and debuggers. And as I walk through things, you can actually see the messages flowing back. You can see the call stacks in the different microservices, which is really kind of nice. They've done a great job moving that forward. In the past, when you program in microservices, logger becomes your friend, print statements become your friend, which is the worst way to program because you tend to forget about them and leave them in and it causes problems. But pay attention to the things you need to do in 1C. Make sure you do understand concurrency. We are going to be using concurrency in some of the microservices that we're going to build in assignment 2. Okay, we're still doing synchronous in assignment 2. Still going to be synchronous. When we get to assignment 3, we're going to do asynchronous microservices. You're going to start seeing message passing instead of REST calls. You're going to start seeing maybe a message bus, and we're going to talk about publish and subscribe and things like that. So there are different techniques that we want to use moving forward there. All right, that's it for today. Guys, I will get you the results of your test by Monday. Make sure you are handing things in on time. It sure makes it a lot easier for me because I've allocated certain blocks of time on Saturday mornings to get this stuff done, mostly when my family's all asleep, which is good because there's a bunch of them and they can demand a lot of attention at times. So